In this lesson, we will look at Unit 2, Section 2.1, the tangent ratio. In this lesson, you will learn what is trigonometry, how to identify and label sides of a right triangle, how to develop the tangent ratio, and relate it to the angle of inclination of a line segment. First, let's look at some new terminology. Trigonometry is the measurement of triangles. It is the branch of mathematics that deals with the relationship between the sides of a triangle and its angles. It is important to note that trigonometry has a wide variety of practical applications that we're going to look at throughout Unit 2. We're going to extend the study of right triangles to determine side lengths or acute angle measures that cannot be found using the Pythagorean theorem, which you used in grade 9, or the properties of similar triangles. Trigonometry is going to be used to measure large distances on land, on water, or in space. It is used often in navigation, architecture, economics, and in a variety of physical and life sciences. So it has a wide variety of uses, and we're going to extend that throughout this unit. A new definition, again, would be angle of inclination of a line or a line segment is the acute angle it makes with the horizontal. And there are many different types of examples that include the inclination angle. And as you can see here in the first example, we have the angle of inclination that is formed with the roof and the horizontal line that is the base of your house. So the angle of inclination is the acute angle between the horizontal and a line segment that is given. Examples include the inclination of a roof or a staircase, the grade or the inclination of a road, or the inclination of a ladder or a ski lift. And as we move on throughout this unit, we're going to study different questions that involve this type of angle. Before we get into too deep with these questions, we're going to look at how to first label a triangle. A right triangle, as you know from using the Pythagorean theorem, has 3 different sides. Previously in grade 9, we just called it the legs and the hypotenuse. But right now we have actual labels that we're going to use for those sides. So when we go to label a right triangle, we have the hypotenuse, of course, which is the longest side. It will always be the side opposite the 90-degree angle. And the other sides are opposite and adjacent. And those will change depending on the orientation of your degree. So we're going to look at that a little later. And a Greek letter, such as theta, is often used to label acute angles, and lowercase letters corresponding to the vertices are used to label the sides. So as mentioned, depending on your location of theta, your opposite and your hypotenuse and adjacent will be a little different. But the hypotenuse will always be in the same location because your 90-degree angle will not change. So as you can see from the first triangle on the left, if our angle theta is in the angle of inclination location, the opposite and the adjacent will be as labeled. If theta is at the top of your triangle, the opposite and adjacent will be changed. So it's important to look at the location of your angle before you label your right triangle. Next, the tangent ratio. Many real-life applications dealing with measurement depend on the vertical and horizontal distances. The tangent ratio can be calculated using those distances only. It does not depend on the hypotenuse side. So when we're talking about using the tangent ratio, we have to use the opposite and the adjacent sides, not the hypotenuse. So the tangent ratio for an acute angle A in a right triangle, the ratio of the length of the opposite side angle A to the length of the side adjacent to angle A. So it's written tan A. So what you have to keep in mind, the tangent ratio only involves the opposite and adjacent ratios, or the opposite and adjacent sides, not the hypotenuse. Those other sides will be incorporated a little later as we go through. The value of the tangent ratio is usually expressed as a decimal that compares the lengths of the sides. So for an example, if tan A equals 1.5, then in any similar right triangle with angle A, the length of the side opposite angle A will be 1.5 times the length of the side adjacent to angle A, as can be seen here in the diagram. If angle A is equal to 0.5, then it will be 0.5 times the length of the adjacent side. So just depending on what your answer is for your tangent A ratio, then it will be that number of times. So using the tangent ratio, we can use it to indicate the measure of an angle that is missing or that is unknown. So in this case, we were looking to determine the measure of angle A, given that the opposite is 12 and the adjacent is 7. So we just substitute that into our tangent ratio formula. So it will be tan C equals 12 divided by 7. You can take your fraction and write it as a decimal. When we do not know the measure of an angle, we have to use the inverse function of tan in order to find that degree. And when we do that, we find that angle C equals 60 degrees. So in summary, angle of inclination of a line segment is the acute angle made with the horizontal. The sides of any right triangle can be labeled opposite, adjacent, and hypotenuse. The tangent ratio is used when given the opposite and adjacent sides of a right triangle. It does not depend on the hypotenuse sides. The tangent ratio can be used to determine the measures of missing angles and sides. As you've seen in this lesson, we determine a missing angle. In our next lesson, we will look at how to find missing side lengths.